Here we go with 3.5 review problems. And we'll start with f of x equals 1 over x plus 4. This is a fairly simple rational function. And the way you graph rational functions, as you see in the notes and videos, is you find and plot the asymptotes first. The simplest asymptote is the vertical asymptote. That occurs at x values that result in division by 0. And we get division by 0 when x equals -4. So our vertical asymptote, which I'm going to abbreviate VA after this, is x equal -4. The next asymptote we should find is the horizontal asymptote, and I'll abbreviate that HA. The horizontal asymptote, there were several different cases when the degree of the numerator is less than the degree of the denominator. The horizontal asymptote is y equals 0, because 1 has degree equals 0. There's no x. It's x to the 0 power is 1. The denominator has x to the first, so it has degree equal 1. So what's happening here is the denominator increases to large values, the numerator stays at 1, and the function approaches y equals 0 for large positive and negative x values. So here I've plotted x equal -4. I've plotted y equals 0. Now we just need to find a couple more points on each side of x equal -4 and some x values. You like to put one x value near the vertical asymptote and one value a little bit away. I'm going to pick an x value -3 and another x value 0. Then on the other side -5, and then a couple units over -7. So what I want you to do is figure out those points, plot them, and see if you can finish this graph. So pause the video and try and finish this graph. So your first thing to do is figure out those y values. We plug in x equals 0, we get 1 over 4, 1/4. X equal -3, 1 over 1 is 1. X equal -5, 1 over -1 is -1. And x equal -7 gives us 1 over -3, or -1/3. And I've plotted all of these points. And on the right side of the vertical asymptote, we see that the graph is trending down, and it's heading towards, it's getting closer and closer to that horizontal asymptote y equals 0, but it's starting to trend up on the right side of the vertical asymptote. So those 2 points tell us what the graph's doing. On the right side of the vertical asymptote, on the left side, we see the graph trending down and then leveling off to y equals 0 from below, and there's our graph. The next function, or the next rational function we're going to look at, is f of x equal 2x minus 1 over x plus 2. The first asymptote you always like to find is the vertical asymptote. I'll abbreviate it VA. And we get that when we get division by 0. In this case, x equal -2 gives us division by 0. And as we get close to x equal -2 in value, this function is just going to increase either to positive infinity or negative infinity. Now, the horizontal asymptote in this case is not y equals 0. In this case, the degrees are equal. The degree of the numerator is 1, 2x to the first. The degree of the denominator is also 1, x to the first power. Since the degrees are equal, we use the ratio of the leading coefficients, 2 and 1. That's our horizontal asymptote. It's y equal 2 over 1, which is 2. The rational function will approach the horizontal line y equal 2 for very large positive and negative x values. Okay, the next thing you have to do is plot these asymptotes and then find some more points on each side of x equal negative 2. And again, we only need a couple on each side. I would suggest 0, negative 1, negative 3, and negative 5 for x values. Find those solution points, plot your asymptotes, see if you can finish this graph. So pause the video, try this on your own. Okay, here we go. Finding all those y values. When x is 0, we get negative 1/2. When x is negative 1, we get y equal negative 3. When x is negative 3, we get 7. And when x is negative 5, we get 11/3. Now, plotting all those and our asymptotes of negative 2 and positive 2, y equal positive 2, 0, negative 1/2, right down here, negative 1, negative 3, down here. Those 2 points tell me that the graph is trending down, heading up. And I guess we could have found an x-intercept as well, which would have been 1/2, 0. That would be that point. But we really don't need it to graph this. Then on the other side of negative x equal negative 2, when x is negative 3, we're up at 7. And when x is negative 5, we're at 11/3, which is 3 2/3. Right about there. So our graph is trending down towards the horizontal asymptote and then heading up on the left side of the vertical asymptote. And that's the graph. Okay, for the next problem, we're going to graph f of x equals 10 over x squared minus 9. Now this one is a little different because when we find the vertical asymptote, there's actually 2 x values that make the denominator 0. So there's 2 vertical asymptotes, x equals 3 and also x equals negative 3. And I'll put these so you can see them. There. So 2 vertical asymptotes. The degree of the numerator is 0. There is no x. And the degree of the denominator is 2. So the horizontal asymptote will again be, like our first problem, y equals 0. The graph's going to head down to the x-axis as x values get large, both positive and negative. And you can see, the denominator is going to get really big real fast with that x squared. So plot all of these asymptotes and then find some more points for this curve. And in this case, you're going to have 3 regions of the graph. So when we plot our vertical asymptotes, x equal negative 3, x equal 3, we have a region to the left of negative 3, a region in the middle, and a region to the right of positive 3. In that middle region, you're going to need 3 points. And I chose 0, 2, and negative 2. When x is 0, we get 10 over negative 9, or negative 10 ninths. When x is 2, we get 10 over 4 minus 9, 10 over negative 5, which makes negative 2. And negative 2 gives us exactly the same thing. This is an even function. Opposite x values give you the same y value. So here I've put plus or minus 4. That's going to give me the same y value. Plus or minus 6 will give me the same y value. So why don't you finish finding all of these y values and plot the points and finish the graph. So pause the video and do that. So when we find the other y values, plus or minus 4 both give us 10 over 16 minus 9, or 10 sevenths. And plus or minus 6, both of these x values give us 10 over 36 minus 9, which is 10 27ths. Now we plot those points, 0, negative 10 ninths, and I've sort of expanded my y value scale just to show the differences better. 2 gives me negative 2, and negative 2 gives me negative 2. So my graph in the middle heads down. It's like an upside down U. Okay, now the other points, 4 gives me 10 sevenths, which is 1 3/7. Negative 4 also gives me 1 3/7. 6 gives me 10 27ths, which is a little less than a half, since 13 and a half 27ths is a half. And negative 6 gives me the same thing, 10 27ths. And those points tell me what's going on the edges. Graphs leveling out to y equals 0, which I forgot to plot here. It's the x-axis. And heading up to infinity near x equals 3 on the right side. We have the middle already graphed. On the left side, we just get a mirror image of the right side because this is an even function. So you remember from 2.5, if the function's even, the right side is a mirror image of the left side. And we see that, and that is helpful in graphing these if you see that a function is even. And also, if you see that a function is odd, you get that effect of 100 symmetry with respect to the origin, meaning this part is a reflection of that part, rotated about the axis. Okay, one more problem to show the other case that we see. This is like number 6 of the homework. Graph f of x equal 4x squared over x squared plus 3. Now first we try to find the vertical asymptote. Well, what real value of x will result in division by 0? Well, the answer is none. Every x value you put in there will square out to a positive if it's a real number. So there are no vertical asymptotes on this type of problem. There is a horizontal asymptote, however. And we look at the degrees. The numerator has degree 2 because it's x squared. The denominator has degree 2 because it's x squared. We take the ratio of the leading coefficients, 4 over 1, so we get y equals 4 over 1, or 4. Okay, so now the only asymptote we have to plot is y equal 4. So we plot y equal 4, and a lot of times students are wondering, well, what points do I pick? Well, First of all, this is an even function again. We have x squared and x squared. Opposite x values will give me the same y value. That means the left side is a mirror image of the right side. We know what the function does way out on the right, way on the left. It's going to approach that horizontal line. We just don't know what's going on in the middle. So all we have to do is find some points in the middle. The best point you could pick is x equals 0, x equal 1, negative 1, maybe 2 more. You don't really even need 2 more, but we'll do 2 more. X equal 2 and negative 2. So find those y values, plot your points, and finish this graph. So pause the video and do that. So when you plug in those x values, 0 gives you 0, 1 gives you 4 over 4, 1, negative 1 the same, 2 gives you 16 over 7, and negative 2 gives you the same. Plot those points, 0, 0, 1, 1, negative 1, 1, 2, 16 sevenths. 16 sevenths is just a little bit over 2, and negative 2 the same. And we just basically connect the points up in the middle, and we know that the graph's going to head towards x equal 4. And so it looks like an upside down normal curve, and that's no accident, because the normal curve function, if you find it mathematically and graph it, has a form much like this. So that's it for 3.5. If you have questions, go to discussions, post them. I know this was a bit long, but there was a lot to do in this section.